Hi viewers, in this video we will see the testing of single phase transformer OC and SC test. OC stands for open circuit and SC stands for short circuit. The OC and SC test are the two tests that are performed on the transformer to determine its losses, impedance, efficiency and voltage regulation. This question arises, why the name OC and SC test? During OC test, the secondary of the transformer has kept open, hence the name open circuit test. During the short circuit test, the LV of the transformer is short circuited, hence the name short circuit test. Why OC and SC test are performed? The OC test is also known as no load test. In this test, the secondary of the transformer is left open and the primary is energized with the rated voltage. The purpose of this test is to determine the hysteresis losses and the eddy current loss. The voltage, current and power are measured on the primary side of the transformer. From these measurements, the no load components are calculated. Circuit diagram for performing the OC test. This is the transformer on which we need to conduct an open circuit test. LV side is used on the primary side and HV side is used on the secondary side, and the secondary has kept opened. And to apply the variable voltage, and single phase auto transformer is used, and a voltmeter which is placed across the input which measure the input voltage, and the ammeter which measures the no load current, and this is a wattmeter which is used to measure the power. The procedure for conducting the OC test: the connections are made as per the circuit diagram. The variac is kept in minimum position, that is at this position, before we switch on the supply. After making sure that all the connections are okay, the DPSC switch is closed. The voltage is increased slowly until the rated voltage on LV side is applied. That can be measured by using this voltmeter. After applying the rated voltage, note down the values: voltmeter reading, the ammeter reading and wattmeter reading. Tabulate all the readings in the tabular column. Bring back this to initial position, that is 0 position. Open the TPST switch and switch off the supply. This is the tabular column. Now we'll see the calculation part. As we know that the power WOC is equal to VOC into IOC cos 5OC. Or this can be written as, I want the power factor during the open circuit test, that is equal to WOC divided by VOC into IOC. After finding the cos 5OC, determine the value of magnetizing current, determine the value of core loss current. Next, get the value of R0 and X0. To determine the formulas for magnetizing current and core loss current, let me draw the phasor diagram. Horizontal line, along the horizontal line I'll take the flux phi m. By an angle 90 degrees we'll get the phasor E1 and E2. Exactly opposite to this we'll get the V1 dash. Along phi m we'll get the current I magnetizing. Along V1 dash we'll get the core loss component. Taking the vector sum of IC and I magnetizing, we'll get the core loss component, where this angle is called as the no load power factor angle phi naught. From this triangle we can write IC is equal to I naught into cos 5OC. Similarly, I magnetizing can be written as I naught into sin 5OC. This is the equivalent circuit operating on no load. This component is nothing but R0, this component is nothing but X0, and current flowing through this is considered as IC, and current flowing through this is considered as I magnetizing. And the sum of these two is equal to the no load current I0. The voltage applied across this will be VOC. So now we can get the shunt parameters, that is R0. R0 is equal to VOC divided by IC, as they are in parallel. Similarly, X0 is equal to the applied voltage is VOC and the current flowing is I magnetizing. Hence, by conducting a no load test, that is the open circuit test, we can determine the values of R0 and X0. Next test is the SC test. Why the SC test is performed? The other name for the SC test is the impedance test. To perform the SC test, the LV winding short circuited, that is secondary winding is short circuited, and the primary is energized with the low voltage. The voltage and currents are measured on the primary side of the transformer. This is common in both OC and SC tests. The purpose of this test is to determine the equivalent resistance and equivalent reactance referred to the primary side, which are important for calculating the efficiency and voltage regulation of the transformer. Circuit diagram to perform SC test, and we'll also see the procedure. This is the LV side is taken along the secondary side and HV side is considered along the primary side, and an auto transformer is used to get the variable voltage. A voltmeter, ammeter and wattmeter is used to measure the input voltage, current and the power. The procedure for conducting SC test. Connections are made as per the circuit diagram. After making sure that the variac is in minimum voltage position, close the DPST switch. After closing the DPST switch, increase the variac slowly until this ammeter reads the rated current. Note down the voltmeter reading, ammeter reading and the wattmeter reading in a prescribed tabular column. After taking all the values, bring back this to initial position and open the DPST switch. This is a tabular column. We know that WSC, that is the copper loss, is equal to ISC square into equivalent resistance, or the equivalent resistance RE is equal to ISC square divided by WSC. This is ISC and this is the WSC. Next, Z equivalent. Z equivalent is equal to VSC divided by ISC. After getting Z equivalent, get the equivalent reactance. Equivalent reactance XC is equal to square root of ZE square minus RE square. Now this is the equivalent circuit RE and this is the equivalent reactance XC. Let me summarize. We conduct OC test. In OC test, the secondary is kept open. We applied the rated voltage on LV side. We noted the values of voltage, current and wattmeter reading. After conducting this, we got the values of R0 and X0. During SC test, we applied the rated current on HV side. Here the secondary as short circuited. We noted the values of voltage, current and wattmeter reading. From this experiment, we got the values of R equivalent and X equivalent. This is the complete equivalent circuit of a transformer. Now we can represent all the values in the equivalent circuit. RE, XE, this is R0, X0,